Now, the beauty of functional notation is it shows, or at least illustrates, the relationship between the variables that are involved. Now, of course, for the earlier examples, we've been dealing with x and y, but they can be any variables. And for the most part, when we come up with these functions, a lot of times those variables represent real-world circumstances. They don't have to be x and y. They could be letters that are used to actually express some sort of real-world circumstance that's built into the problem. So here we have this example. It says the M224 60 millimeter lightweight mortar is a muzzle-loading, high angle of fire weapon commonly used by the U.S. military for close-in shelling of enemy troops. One particular elevation and muzzle velocity of a mortar fired will have a height, h, and we have height, so we're using h rather than x or y. A height h in feet can be modeled with the function, and here it is, h of t, so that's how that's pronounced. H of t is equal to negative 16t squared plus 494t plus 200, where t, and here we have t rather than an x and a y, is the seconds after firing. Find the height of a mortar 10, 20, and 30 seconds after it's fired from the M224. So as we look at our function here, I'm just going to go ahead and repeat it right here. We have h of t, so the height right here is dependent on the time t. So t here is our input variable, and our output is negative 16 t squared plus 494 t plus 200. This function represents the relationship between the height of the mortar after it's shot after so many seconds has gone by. So we'll determine the t. So we have a height after 10 seconds. That's going to be equal to negative 16. T is 10, so we do 10 squared. I like to place it in parentheses like this. Plus 494 t, and that's 10, plus 200. So what is the height after 10 seconds? The height, and we go ahead and we just simply do the arithmetic here, negative 16 times 10 squared, plus 494 times 10, plus 200. That's 3,540 feet. And we'll do the same for 20 seconds. After 20 seconds, when the time is 20 seconds, what will the height be? Again, that's negative 16, 20 squared, plus 494 times 20, plus 200. So after 20 seconds, the height is 3,680 feet. And then we want to know after 30 seconds after it's been fired. So here's our time t, 30 seconds. That's negative 16 t squared, 30 squared, plus 494 t plus 200. So after 30 seconds, the height is 620 feet. So you can see here as the time is 10 seconds, we're at 3,500 feet or a little over. 20 seconds, we're even higher. But at 30 seconds, we're at lower, because you can imagine that when a mortar is fired, it goes up and eventually it starts to come down. So maybe at 10 seconds, it's at a height up here. Maybe 20 seconds, it's at a height up here. And then maybe after 30 seconds, it's at a height up here. That's why it's a smaller height. And this particular shape is known as a parabola.